Hello, the paper we chose to analyze is called Design of 2 Degree of Freedom PID Controller for Temperature Control Systems. This paper was published by Mr. GL-Mook and Mr. C.B. Kadu from the Department of Instrumentation and Control Engineering at Pravara Rural Engineering College in Lani, Maharashtra, India. The design of a 2 degree of freedom PID controller for temperature control systems. In every process industry, there are two important aspects. 1. Set point tracking, R of T, and 2. Disturbance rejection. Both of these aspects conflict with each other. In practice, this cannot be fulfilled with a 1 degree of freedom PID controller. Therefore, we need to choose a 2 degree of freedom PID controller to solve this issue. The problems with a 1 degree of freedom controller are: set point response will be oscillatory when trying to obtain the disturbance response. The disturbance response deviates when trying to obtain the set point response. In conclusion, both responses cannot be achieved at the same time. Only one can be achieved at the expense of the other. A 2 degree of freedom controller. A 2 degree of freedom controller has set point weighting on the proportional and derivative gains. It consists of two inputs, the reference signal and the feedback signal. The new signal produced is the difference between the two. The advantages are that the 2 degree of freedom controller results in smooth set point tracking and good disturbance rejection. The following is an example of a typical 2 degree of freedom controller. As an example, we will design a 2 degree of freedom temperature control system for use at the site building. We will place a temperature sensor inside the office of Dr. Habash. Using a 2 degree of freedom controller, we will control the process. Here is our temperature sensor. The process pertaining to this temperature sensor is P of S equals 1 over S plus 1 multiplied by a transport lag with a time delay of 0.2. The following are the plots for the step response for the set point tracking. The first plot in the top left corner represents the step response for the set point tracking without a load disturbance. The second plot represents the step response for the set point tracking with load disturbance. As you can see, Using 2 degrees of freedom has resulted in a smooth set point tracking and a good disturbance rejection. Finally, to make the system robust, we will make an adjustment to the process and will now use P of S equals 1 over 1.2 S plus 1 multiplied to a transport lag with a time delay of 0.16. As we can see from the third plot on the bottom right corner, the system has become robust.